Thanks for stopping by the eCave today. In this episode, it's a continuation of my adventures with the IBM PC 5150. In this episode, a fair few things have happened, so if you want to see that, why not step inside? Thanks for stepping inside. In this episode, it's more about the IBM PC 5150 I'm working towards restoring. This episode is about some trials and tribulations in relation to diskette drives, but in the last episode, I actually had cleaned them up and they were pretty much ready to go. I even had to replace one of the spindle motors from the spare drive, and we were then pretty much ready to boot up some DOS. However, what's happened since then is the simple fact that I've had nothing but problems with the diskette drives. So this episode will cover those issues. I tried to boot up the DOS diskette, but to my dismay, that would not work. I even took one of the drives and took it to another machine I have as a reference machine, where I create DOS diskettes, and I formatted and created a DOS diskette on the actual drive, put it back onto the IBM PC as an A drive, but when I booted up, it couldn't even recognize its own formatted and written diskette. I knew there was some trouble ahead. I took the diskette drive back to the reference machine and had no end of problems initially because I was using the terminator on the diskette drives, which I shouldn't have. After having finally figured that out, I realized I had to put a stake in the ground and understand what diskette drives are functioning and which ones aren't. So this episode is about that adventure. Now, the first segment I'll show you is me finally realizing I have to analyze the diskette drive I have on the reference machine, or I call it a reference machine. I'll show you what I mean, in order to make sure that diskette drive was reasonably well aligned to the tracks using OEM diskettes. Once I had established that, my next episode is showing you the troublesome drive and what it was doing or not doing, depending on your point of view. And the last segment is about the spare drive, which I had to press into action and see how well that is track aligned. Along the way, I'm using the image disk utility, which is written by David Dunfield. What a fabulous piece of software to help with track alignment, I must say. Now, I'll give you a bit of introduction to the diskette alignment process and some of the things it shows in case you haven't seen that before. I also throw in a small segment about cleaning the PCBs, as I don't have ultrasonic cleaners and stuff like that. I just use some elbow grease, and I'll show you how. Without further ado, let's kick into the reference PC, and I'll show you what I finally ended up having to do. And I'll come back at the end and show you what we have planned for next week. So this is my IBM PC 300GL, which I use as a diskette creation machine, so to speak. I've got a TIAC FD54B 360K drive, which I use to cut the 360K diskettes. And then there's a 144 3.5-inch drive there as well. Now I usually boot it up from the Windows 98 floppy disk when I'm working with DOS disks, but I also run Windows 98 OEM2 version on it. That's why I have a mouse over there. Now I've set this up so you can see how I do the head alignment. The first thing to know is that I've hooked up the probes onto the diskette drive, test point 9 and 10. And I've got my oscilloscope there, ready to show the strength of the read head. So we can see any differences. I'm using IMD to do the exercise of the drive, and I'm putting in a formatted diskette from this drive, so it was formatted in this drive. But I'll also be using at least 3 OEM diskettes written through diskette duplicators, which should have the tracks correct. So it's an IBM disk, a Lotus 1 to 3 diskette, and a Microsoft MS-DOS diskette. These are all pre-written ones. It's not enough to format in your own drive, because that will be the optimal track alignment. You need to test OEM diskettes and align the drive to the OEM diskettes. But I'll show you, here's the optimal level of the read signal for a cell formatted diskette. So let me start the IMD, but before I do that, let me explain a bit about that. So I've already configured it. As you see, the drive is the B drive. Cylinders are set for 40 tracks. They often refer to cylinders as tracks or tracks as cylinders. I haven't seen any big difference, but some people say cylinders refer to both sides of the disk. So technically it should say cylinders if there are 80 cylinders, 40 each side. But for whatever reason, you can equate cylinders with tracks. This diskette has 2 sides, and because it's a native 360K diskette, we have double step off. Those are the only things I've changed, because all the other bits are default. So let's kick off the analyze, and I'll explain what the analyze does. First of all, as you see, you can see IMD doing its beep because it's happy with what it's seeing, and you can see the read levels on the oscilloscope. So I'll put that onto the screen. But before we go any further, let me pause this and explain a bit. It's probably better to do that, otherwise we get the drive running. As you see, the top line in the red part of the IMD screen tells you the current setting. It's B for the B drive. The read and write bandwidth is 250K. DD is the double density. T0 means it's at track 0, and H0 means it's selecting head 0. And then you have the 5 letters, which are either lowercase or uppercase. The first one, small f, means everything is fine, but if it's capitalized, it means a failure has occurred. The small w means the diskette is not write protected. If it was a capital W, it would be write protected. The R, it actually means the drive is ready, i.e. the speed is up to speed. and it can sense the index pulses. The Z, capital Z, means it's at track 0. If you increment it by 1, Z should drop to a small z because it's now detected it's away from track 0. And the D simply means it's double-sided. Now, next you have 9 by 512. These are the sectors, and each sector has 512 bytes. And then you have the gaps, 24 and 64, which are standard for the 360K diskette. And then you have the single step, telling you it's in single step mode. Below that is what the bar graph that shows you which track you're on. And then you have a set of 3, or actually 4 numbers. The one right under the 2 of the bar graph, 0, tells you the track number. It's reading off the diskette. Now, here's something to know. When it says T0 at the top, the track it's reading off the diskette should also say 0. So those have to match. But sometimes, if the diskette is misaligned, or the heads are very misaligned by a whole track, T0 might be there, but the track underneath the 2 there could say 1. So bear that in mind. The next number 2, which when it's exercising runs through different digits, is just showing the number of sectors being read for that revolution. The next one, 18, shows the number of successfully read sectors on the track. Now, we know that there are only 9 sectors per track, per side, 18 in total. So I don't know why it shows 18. It's maybe showing that it's read it twice. The last number, the 0, shows you the failed readings, or number of failed read sectors. But as you see in our case, we are completely successful. You see straight away on the oscilloscope the strength from the read head 0 is pretty good. We're getting, 2 over 2 volts peak to peak, almost 3 volts peak to peak. I'll stop the beep. The beep is there to indicate how many sectors are being read per track. The higher the beep, the better the alignment. But you can see it's pretty good. Let's go out to track 20. And as you can see, it's still pretty good. The read head amplitude has fallen slightly on head 0. I've also noticed the head 1 has a slightly lower amplitude. I'll show you that. It's slightly lower as well. But let's go to the end of the tracks, which is track 39. To get there, we press key 4 and then -1 to get 39. And as you can see, it's still reading fine. The amplitude has now fallen down to about 300 volts peak to peak on head 1, but head 0 is slightly higher. So that's pretty good. So what I'll do, I'll use my reference diskettes, the MS-DOS 5 one and the Lotus one and the IBM one, and I'll record all the voltages at the different head locations. I'll show you in a spreadsheet. From what I can see, I probably don't have to align or change the track alignment on this drive. It seems to be okay. I continued with the TIAC formatted diskette and then recorded all the voltage amplitudes displayed on the oscilloscope for both heads at track 0 and then tracks 10 16, 20, 30, and the last track 39. I then removed the diskette and inserted one of the other diskettes and repeated the measurements. I collated all the amplitudes into an Excel spreadsheet, and once I did that, I created these two charts where I plot the amplitude strengths for all the diskettes, both for head 0 and for head 1. On the left you can see the amplitude for head 0. The top green line is the TIAC formatted diskette amplitudes, and I'm just highlighting the wattage levels. And down here are the tracks 0, 10, 16, 20, 30 and 39. And the left side here are the amplitude volumes. Now the same thing is here on the right with head 1 amplitudes. And what you see straight away, as I've noted previously, is that the head 1 has a lower amplitude than head 0. But that doesn't seem to be a problem. There's a very good correlation between the levels for the formatted TIAC diskette and the MS-DOS diskette. They follow each other pretty closely. Then you have the blue one here, which is the IBM diskette, which seems to be all over the shop. And the Lotus 1 to 3 diskette, the yellow one, is a bit weird as well. It actually, on head 1, has a higher volume at higher tracks. The lowest recorded amplitude was on the IBM diskette on head 1, almost around 300 millivolts. Now, I then proceeded and tried to copy all the data off these diskettes, and the drive had no problems with that. So I see no reason to start meddling with the track alignment of this TIAC drive. I'll leave it as it is, and I'll calibrate or track align my IBM diskette drives to the formatted TIAC diskette. That way, anything I create in the TIAC drive should be readable in the other IBM drives. Now, next I'll show you some of the weirdness in one of the diskette drives, which in the end I had to put aside. This is the IBM drive that's been giving me a lot of problems. I've hooked it all up and I've got a formatted 360K diskette from the TIAC drive, which is my reference. I've got the probes on TP1 and TP2 to check the amplitude, and I've got the oscilloscope going. So let's start the alignment test with IMD by pressing A and enter. And as you can hear, the beeps are there, and the amplitude on track 0 seems to be pretty much the maximum it can be for these IBM drives or tandem drives, around 600 millivolts peak to peak. I'll stop the beeps. What IMD tells me, it says it's on track 0, head 0, and we have said as a capital, meaning we're on track 0 physically. The switch is on. Now if I go to 1, the capital Z will go to a low Z. And sorry, I went to 10. IMD tells me at the top it's set the stepper model for track 0, it's selected head 0, and we are at position 0 with a capital Z. If I increment by 1, the capital Z should go to a lowercase z because it's off the switch. And now I'll put it back. So that's track 0. and we're getting plenty of amplitude. If I want to go to the middle of the drive, like track 20, see what happens. The amplitude isn't too bad, but IMD thinks it's on track 20. It's actually reading track 24, not track 20. So there's something wrong with this drive. If I go to track 30, for instance, once again the amplitude drops a bit, but instead of thinking it's on track 30, it says it's reading track 34. So, and for the life of me, if I go to, for instance, track 20, now it's on 19, if it goes backwards. If I adjust it to 20, it will not go to track 0. So I think there's something wrong with the stepper motor. As I've shown you before, the rails have been lubricated, and it takes less than 200 grams to shift the carriage, which is pretty normal for these drives. It should be less than 200, all the way down to 150 grams. But this is tracking all over the place. If I go to 30, now it's on 30. You think I'd be happy with that? Of course not. If I go to the last track, say 31, 32, let's go to 40 minus 1. It now thinks it's on 38. And if I go back to 20, it now thinks it's on 12. So there's something majorly wrong with how the stepper motor is moving the head. Now let's go back to 0. And now it thinks it's on track 1 instead of 0. Yeah, I'll have to take that stepper motor apart, I think. But I will press into service my spare drive, because I want the 2 A and B drive functional on the IBM PC. And hopefully that one is working better. This is the PCB from the spare diskette drive, and I'll show you how I clean it. Let me first take the plastic clips off. So I can get underneath here. Well, I don't have to take it off all the way. So what I do, I have a PCB cleaner solution here, and I just put it into a spray can, and I just spray liberally on it, both sides. And then what I do, I have a anti-static brush, and the best thing to do is just to brush it back and forth. I pat it a bit. This PCB cleaner is supposed to be used in ultrasonic machines, but I find it works just as well doing this. And it cleans up the boards pretty well. Now, one of the things I also do is, once I've done this and patted it a bit with a cloth, I spray some isopropyl alcohol on it and use an air compressor to blow that off, and then let it dry for a while. So I'll just pat it down a bit with a cloth. And then I'll take it outside and I'll show you how I put the isopropyl alcohol on and spray and use a compressor, air compressor, to get it off. So let's do that. I'll do the other side. And then we let it dry a bit. I'm back again with the same reference formatted diskette, and this is the extra spare drive. I've shifted the spindle motor across and cleaned it up a bit. Hopefully it works fine, but we're about to find out. So let's check the alignments for this drive, which I hope is not going to play up like the other one. So put the diskette in, fire up IMD image disk and press analyze and see what we get. All right, it looks to be happy. I'll stop the beeps. It's reading all the sectors. It thinks it's on track 0 as it should be, and everything looks fine. The amplitude is approximately 400-500 millivolts on track 0. So let's go to track 20. And we're reading track 20, which is all good. The amplitude is now around 3-4, probably around the 350-400 millivolt. And if we go to track 39, that's 4 minus 1. We're still reading all the sectors according to IMD. We're on track 39, it's happy, and the amplitude is around, around the 300 milliwatt range. That's about as good as these drives can get. I could go in and fine tune it a bit, but I'm hoping this will be good. I'll only do that if it's having problems with any of the diskettes. Now let's try some of the other diskettes. I'll just do a directory on them. Let's go back to 0. Quit out of IMD. And I'll put that one away. I'll put the DOS diskette from Microsoft. And we'll say DIRB. Might help if I actually press any keys. And what I'll do a copy. B start to C / IMD. I've got a dump directory there. Yeah. See if it copies everything off the diskette. Looking promising. Seems to be able to read it, which is good. That makes me happy. I can then use it on the 5150 PC. Just to make it even more harder, I'll give it the porous diskette, as you have seen on the spreadsheet. So we'll repeat that from the IBM font diskette. If it reads that, then it's all good. Oh yes. Fantastic. I'll do the Lotus one as well. As long as it reads those three, we're in good alignment territory. No reason to touch the adjustments. This diskette has one big help file, and it copied. Fantastic. I'll stop it here then. Well, I hope this episode has been informative, especially when it comes to diskette track alignments. That's a whole chapter and verse by itself, I guess, but I've learned a lot. So now my PC happily boots from a DOS diskette and reads the secondary diskette as well, so it looks like it's working fine, or at least I hope so going forward. As you can see, we have DOS 3.3 loaded up here. Now the PC only has 256K memory, so I've gone through my ISA card stash and I picked out a few memory expansion cards which I might test in the next episode in order to see if I can expand the memory to 640K, which I think would be the minimum I'd like to have in the machine, because that allows me to run a variety of programs as well. So in the next episode, I'll be doing precisely that, and maybe some more. We'll see how time pans out. These things tend to take a while. But until then, thanks for visiting the eCave.